Tap, tap, tap. If you have ever said the words, when am I ever going to use this in real life? You need to listen to this video. Please, may I have your attention while I show you some amazing things, because this is real world math. This is where I get super excited. This is where I teach you how to not get so far into debt that you're just like, oh my gosh, or how I teach you to watch what happens to your money when you borrow it or when you invest it. This is where it all starts, okay? So what I want you to do first is grab your notebook, and you're gonna wanna write some notes down. Here we go. These notes are going to be our first notes. Here's our formula. Y equals A, parentheses, 1 plus or minus the R, which is our rate, to the power of T, which is our time, generally in years. Your rate is also in a decimal form. So if you have 8%, it would be 0.08. Remember, for changing something from a percent to a decimal, there's 2 dots and a percent sign, so you move your decimal 2 spots over. Okay, I have a little highlight here. Pardon my aesthetic. Look at this, I've got some highlighters. We're gonna highlight this because this is super important. That plus minus, I love the aesthetic of these highlighters. So that plus minus is super important here, because if it is plus, it is growth. If it is a minus, it is a decay. What in the world does that mean? It means if it's growing, it's gonna be more than 100%. This 1 represents 100%. So let's say I say, hey, this thing is growing by 5% per year. It's not only growing 100%, it's growing an additional 5%. So that would be 1.05 as a decimal. As a percent, that would be 105%. What if it is decaying? I say, hey, this thing is shrinking by 11% per year. That means we take our 100% and we minus 11%, and we end up with 89%. See how this is the decimal form of that? That means year after year, it's only 89% worth what it was the year before. So it keeps constantly decreasing. Now, where is this the best value? Let's pause and talk about this. Okay, guys, so I am looking to dive right into this and get into those problems. But before that, I actually want to teach you how to maybe scam some money out of your parents or your guardian figures. If you get an allowance, I want you to do this allowance with your parents. So take notes. Here's what we're gonna do, but this is a great way to demonstrate exponential growth. All right, so what you're gonna do is you're gonna go to your guardians, your parents, whoever you live with, and say, listen, I want an allowance. And they're gonna say, okay, yeah, how much? And you're gonna say, no, it's not bad. It's just 1 penny. But I only want 1 penny on the first day. And then I want you to double it every day after that. Your parents are like, yes, this is fantastic. A penny? Sure, here is a penny. You're like, okay, thank you. And then you're probably thinking, that teacher is terrible. Why would I do all this work for a penny? The next day you get 2 cents and you're still cursing me. You're like, I can't do this. This is terrible. Day 3, you got 4 pennies. Okay. Day 5, you're getting 8 pennies, right? Let's look at the end of the week. Okay, you're up to 64 cents. Maybe you can buy like a soda with all that. I don't know. But you're getting there. Your parents are like, yes, this is the best allowance we have ever done, right? So you go, now you're up to $1.28. Okay, that's pretty nice. You can buy a soda. Now we're up to $2.56. Let's take a look at where we are after 14 days. 2 weeks in, and you are getting $80 that day. $80. You remember, we started with 1 penny and we doubled it, and you told your parents, I want 1 penny, we're going to double it every day. And you are now at day 14, and they're like, $80 for the day. What? And then of course the next day is $160. $160. You can see how this is rapidly increasing, all starting from 1 penny, right? If you were to take a guess, I want you to pause the video and guess, at the end of 30 days, how much do you think you have? Probably like $10,000, right? 5,000. Friends, if you did this all the way to 30 days, look how much you're getting on a daily basis. At the end of 30 days, doubling a penny, just doubling a penny. You've $5.3 million on that last day. And look at this. That doesn't include everything before this. Of course, now at this point, your guardians or your parents are going to be like, find that teacher, she is terrible, oh my gosh. But this is what exponential growth is. You can see how things grow really fast. you're all kids, so you're probably familiar with things going viral on the internet. That is exponential growth as well. So that is why this unit is exciting. We can take something small and grow it really, really fast. It applies to money. So let's talk about that. We're going to go, but I think that's a fun little experiment to do with the parent figures in your life. So let's talk about how we can apply this in other real world situations that are not getting an allowance of $5 million from your parents. Okay, our first example we have here is you have purchased an antique table for $450. The value increases by 6% per year. Okay, fancy antique table you have there. So the first thing that we're going to do is we're going to write down, well, we know that it is increasing. So that means we are growing, exponential growth. So we're going to write down our formula and say, okay, y equals the amount 1 plus our rate and then time. So let's write that formula. It would be y equals our starting amount is A, and our starting amount is $450. And then we have 1 plus our rate, and it's 6%. Remember to turn this into a decimal. So 2 dots, 2 spots, 0.06. And then T is our time in years. So y equals 450 times 1.06, because after 1 year, your table is not only worth $450, it's also worth the 6% on top of that. And if we do some quick calculations here, if you do 450 and you get 6%, that's $27. So your first year, you're going to be earning $27. Now your table is worth 450 plus 27 gives us 477. So the next year, our starting amount is 477, and you'd be growing 6% on top of that. Rather than make you fill out a table the entire way, it's easier just to use this formula. So what is the value of it? Value after 5 years. 5 years. Well, so this is the equation that we're going to use. So I'm going to go ahead and box that. And remember, T is our time in years. So we're going to say y equals 450. I don't know why my camera does that. I'm so sorry. It's bumping in and out like that. 1.06 and then to the 5th power. So this you have to do on your calculator. 1.06 to the 5th power. 1.06, sorry about the light there, to the 5th power gives me this weird number. I'm not going to write that down here. I'm just going to automatically hit times 450. Times 450. And we end up with $602.20. So $602.20. So after 5 years, your table is now worth $600 roughly. You paid $450 for it. Good investment. Let's look at this one. You deposit $1,000 in an account that pays 7% interest. How much will you have in 30 years? Now, I know most of you are probably early teens, 12 to 15 years old right now, and you think 30 years is a long time. Let me tell you, it's not. It comes so fast. And in 30 years, you're going to be looking at retirement. Maybe not quite then, maybe 40 years for how old you are now. So you're going to be looking at retirement. And retirement means that you need to have enough money saved away so that you can live, because you're not going to be working anymore. And you don't know how long you're going to live. So you got to save money so that you have money to live until you're, 90, 100, right? And so we put money away, and when we put that money into an account, we're investing it, which means that bank or whatever we're investing in is paying us to hold that money. So for example, this $1,000 in an account that pays 7% interest, after the first year, you've earned 7% interest, right? So we've got 1,000, let me show you, times 0.07, that gives us $70. So at the end of the first year, you've made $70 for doing nothing other than leaving your money in there. It's amazing, right? So the next year, you're starting with $1,070 and you're earning 7% on top of that. And that gives you now you're getting $75 instead of, I get very excited about this, $75 instead of just $70. After 30 years, that compounds quite quickly. So let's talk about that. We have y equals the amount 1 plus r to the t power, and our amount was $1,000. And so let's say you're a smart 12 or 13-year-old kid and you put it in for 30 years. So when you are 42, 43, you've got your money. So we're doing 7% interest, 0.07, and we want to do t is 30 years. So 1 plus 0.07, 1,000 times 1.07 to the 30th power. So that's supposed to be a 30. I don't know why I wrote it like that. Okay, 1.07 to the 30th power. This gives us that big old long number, 7.61. Okay, so that's this thing right here. We're going to multiply that by 1,000. So times 1,000, which is really just moving the decimals over. We end up with y equals $7,612.26. We're rounding up there. That is, you have just made $6,612.26 for doing absolutely nothing, just putting that money away. You put that money away, you didn't touch it. Imagine if that had been $10,000. So let's say your parents are super nice and you, upon graduation, your parents, a long lost aunt, a favorite sibling, I don't know, somebody says, here is $10,000. And you're like, yes, I'm going to go out and buy a car. No, don't go buy a car. What you're going to do is you're going to take that and you're going to deposit that money into an account that pays, let's say, 7% interest. And again, 30 years. And 30 years is pretty early because you're not going to be retiring, right? So, because that's if you're 18, that would make you 48. And usually people retire about between 55 and 65. So it's right before retirement. So you know what? Let's say 40 years. 40 years. So that gives you retirement, right? So we have 10,000 times 1.07 to the 40th power. Again, we're going to plug that into our calculator. 1.07 to the 40th power. Whoops, there we go. You get this big crazy number and we're going to multiply that by 10,000. 1, 2, 3, there we go. There we go. All that's doing is moving our decimal over. You have taken that $10,000. You have turned it into $149,744.58. You took $10,000 when you were 18, and when you went to retire, you could buy, I don't know, maybe a small condo or something. Houses are kind of expensive, but that is a significant amount of money, $150,000. You had $10,000. You just made $140,000 for doing nothing. This is what rich people do. They have money that makes them more money, and they keep investing that money. So that's what I want you to take away from this, is that if the sooner you can invest money, the better off you are going to be, because time is on your side right now, my young friends. Time is on your side, okay? Let's take a look at this next one. You spent $30,000. If I have not lectured you enough about money right now, we are going to talk about cars. You spend $30,000 on a new car and it depreciates by 15% per year. Depreciate means it goes down in value. Appreciate means it goes up in value. When something depreciates, it's not an asset. That thing is a liability. Because if you take out $30,000 on a new car and the next year that car is only worth $20,000, but your loan is still at like $25,000, you can't even sell the car to pay off the loan because you're now what we call upside down on the loan. So you got to be really careful here. I know when I gave you that example of, a great aunt or a great uncle gave you $10,000 at graduation, don't spend it on a car, go invest it, because $30,000 on a new car, I see a lot of young kids do this. It depreciates. So let's talk about that. This time it's depreciating, so that's going to be a decay. So we have 1 minus our RT. So y equals 30,000, and then we have 1 minus our rate, which is 2 dots, 2 spots, so it's 0.15 to the t power. So y equals 30,000, sorry about the weird comma there, 30,000, 0.85 t. So that 0.85 is just the decimal version of 85%. That means after your first year, the first year you have it, the car is worth 100% for what you paid for it. The next year, it's only worth 85% what you paid for it. So every year, whatever it was the year before, you're taking 85% off of that. So that's where we get these numbers from. It's only worth 85% because we're taking away 15% every year. So what happens if that, or what will that car be worth in 4 years? So we say $30,000, 0.85 to the 4th power. So we say 0.85, probably helps if I do that, to the 4th power, and then we're going to take that number and we're going to multiply it by 30,000 here. Don't round your decimals because it'll round too soon and you'll be off. We end up with $15,000. In 4 years, that car is less than half of what you paid for it. And I can guarantee you probably haven't even paid off the majority of the car yet. You're still probably paying interest, and we'll talk about that in algebra too. Okay, that's the most of what I've got for today. However, I have one other problem that is sort of a challenge problem. If you would like, you can stick around and watch this one, but I've given you the gist of this lesson. So on this one, here we go. When a person takes a dosage of I milligrams of ibuprofen, the amount A in milligrams of medication remaining in their bloodstream after T hours can be modeled by this equation here. Find the amount remaining in their bloodstream for the following dosage and elapsed time. So this is again a real world use of exponential growth and decay, because the medication is gradually decreasing each hour that passes. So after 1.5 hours, they've taken 200 milligrams. Let's go ahead and plug that in. So we say A equals, and I represents the milligrams of ibuprofen. Notice that that's our starting amount. So that's going to be 200 milligrams. Now, 0.71, remember, this is a decay because this is less than 1. We took 1 and we subtracted. So if we do 1, oops, let me show you. So if we do 1 and we subtract 0.71, we get 0.29, which means this is decreasing by 29% every hour. So we've got 0.71, and then we've got 1.5 hours. So 0.71 to the 1.5 hour gives us that number. We're going to multiply that by 200. 200 there. We end up with 119.65 milligrams remain. So after an hour and a half, there's about 120 milligrams remaining. So it is still quite a bit. That's probably why you usually only take ibuprofen every 4 to 6 hours, something, or 6 to 8 hours, right around there. And that's so that it can get all the way out of your bloodstream, so you're not taking too much at a time. 400 milligrams, 5 hours later. So same idea. We have 400, and we say 0.71 and then times 5 hours. Now, normally our time represents years, but you can, if the problem establishes T equals time in hours, then you can use it that way. So A equals, that's why I said this is kind of a challenge problem, because it's a little bit different. Up, and we go 5 like that. We end up with 0.18, and then we times that by 400. And we end up with 72.17. So this person has 72.17 milligrams remaining in their bloodstream. Hopefully you have found this helpful, and I look forward to seeing you next time.